Hello, welcome to Chapter 7, Homework Questions 96 through 102. Question 96. Suppose you know that triangle TAP is congruent to triangle DOG, and that TA has a measure of 14, AP has a measure of 18, TP has a measure of 21, and DG is equal to 2y plus 7. On your paper, draw a reasonable sketch of triangle TAP and triangle DOG. So I went ahead and drew a triangle that appeared to have the longest side of TP be 21, AP is 18, and TA is 14. We also know that we have another triangle that is congruent to that, so just to kind of try to show another picture, and this one is DOG, so it has to go in the same order as that one. And they are congruent, so we know this is 14, this is 18, and this is 21. But it also tells us DG has the expression of 2y plus 7. And so we've done part A, which is to draw the sketches, and then part B is to find the y value. Well, now that we know that TP and DG are congruent, we know that 21 is equal to 2y plus 7, 14 is equal to 2y, and therefore y is equal to 7. And so that was part B. Question 97, graph the equation y equals negative 3/2 x plus 6 on your graph paper. We know that the slope is negative 3/2, and we know that the y-intercept is 0, 6. So we can go ahead and plot the y-intercept, and then we can do our slope triangle, down 3 to the right 2. You can do that plenty of times on a 10 by 10 graph. Also, you could go up 3 and to the left 2. That means a positive 3 and a negative 2, but still forms the line. It is a negative slope, so you can see it going down. And so we'll just kind of draw on that line the best we can. And then label the points where the line intersects the x-axis. So we know this one, which was at 0, 7, or 0, 6, because that was the y-intercept. And then on the x-axis, it crosses at 4, 0. Question 98, angle A, angle B, and angle C are exterior angles of the triangle below. The measure of angle A, the measure of angle B, and the measure of angle C, or find them, and then find the sum of all three of them. So what do we know right now? Well, we know that the angles of the sum of the angles of the triangle are 180, but we also know that these are all straight angles as well, so we know they add up to 180 as well. So let's first find the third angle of the triangle right up here by taking 180 and subtracting 72 and 48. And that will give us a value of 60 degrees. So that's not angle A, B, or C, but it allows us to find angle C because we can take, this is a straight angle, so 180 minus 60 means that C is equal to 120 degrees. We can also do 180 minus 72 to find angle B, which would be equal to 108 degrees. And then the same thing, 180 minus 48, and that's 132 degrees for angle A. So we'll write all three of those out. Measure of angle A is equal to 132 degrees. The measure of angle B is equal to 108 degrees. And the measure of angle C is equal to 120 degrees. And then at the end, it wants us to find the sum of all three of those. So add all of those up, and then that will give us the sum of angle A, B, and C. And that will give you 360 degrees for the sum of all the exterior angles of the triangle below. What do you think? Do you think that will be true for all triangles and their exterior angles? Something we might have to look into a little bit more. Question 99, the principal's new car cost $35,000, but in 3 years it will only be worth $21,494. What is the average annual percent of decrease for the 3-year period? So there's a couple ways that we can approach this. The first way, or the first thing I'm thinking of, is initially the car is worth $35,000. Let me take out my comma just so we don't have separation there. So that's the initial, but in 3 years, it's already going to be down to $21,494. And it is a percent of decrease, so you can see that it's going down. So one way that you potentially could set this up is to set up a table and kind of work your way through it. That we know at time 0 it's 35,000. We don't know what it is at time 1 or time 2, but at time 3 it's 21,494. we know that there's a decrease here, so 35,000 should be multiplied by some value of b, which is the multiplier, and then again from 1 to 2, and then again from 2 to 3. So it gets multiplied 3 times before you get to the 21,000. So we could set up an equation. 35,000 times b times b times b, or b cubed, is supposed to equal 494. And now we could solve that by dividing both sides by 35,000, I'm sorry. And then b cubed would be equal to that value. And b cubed is approximately 0.614. Now I will just leave that number in the calculator. And it's b times b times b, so we can take the cube root to undo that. So we want to do the cube root of b cubed and the cube root of 0.614, and then that will give us b's approximation. So we can take the cube root of that previous number, and we get approximately 0.84 and then 39. So I'm going to go 0.85. So now we know that the multiplier is 0.85. That means that we started at 100% and we subtracted 15% to get to the 85%, or the 0.85, because that's what it represents. And so what is the average annual percent of decrease? Well, the average annual percent of decrease would be the 15%. It's not decreasing 85%. It's decreasing from 100% down to 85%, which is a decrease of 15%. So it's a 15% decrease. Question 100. What else can you prove about parallelograms? Prove that if a pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral must be a parallelogram. For example, for the quadrilateral ABCD, given that AB is parallel to CD, and that AB is congruent, line segment AB is congruent to line segment CD, show that BC is parallel to line segment AD. Organize your reasoning in a flowchart, then record your theorem in your theorem toolkit. All right, so what is given to us? Well, you can see that they are telling us that the side lengths AB and CD are parallel and that they're also congruent. So that will be our given in our flowchart. All right, if we can prove that the triangles are congruent, then we can prove that their corresponding parts are congruent, and then potentially prove that lines BC and AD are parallel. So let's work on proving the congruency. So one thing that we know, since the lines are parallel, we know that angle BAC and angle DCA would be congruent, and that's because you have parallel line, cut by a transversal, so those would be your alternate interior angles. We know that they are congruent. So let's add that to our flowchart. All right, and that's going to come down from the parallel lines, because that's why we know that. We also know that this side length right here of both triangles are congruent to each other. So AC, line segment AC is congruent to line segment CA, and that's the reflexive property. And that doesn't come off of either the given bubbles because it's just the same side of two different triangles, so that's the reflexive property. And then what we know, now you can see that we have a side length, an angle, and then a side length. Same thing here, a side length, an angle, and then the same side length here. So we know that the two triangles are congruent by side, angle, side. And then now that we know the triangles are congruent, we can say that the angle of BCA, so this angle, and DAC are congruent because congruent triangles have congruent parts. So now from the, well, I guess I forgot my arrows. So we have the reflexive property for that one. This side length was given, and then this angle. So those all three led to that. And then now we'll have another arrow that leads to angle BCA being congruent to DAC. And then now since we know that those angles are congruent, then we know that line segment BC and line segment AD are parallel because of alternate interior angles being congruent. So if alternate interior angles are congruent, then the lines must be parallel. And so I think we have officially finished. Once again, we proved that the triangles were congruent so that its parts were congruent, and then we were able to say that line segment BC is parallel to AD, which means we have two sets of parallel sides now, so therefore it's also a parallelogram, which is why we were trying to prove that line segment BC and AD were parallel to begin with. Question 101. As Miss Norman looked from the window of her third-story classroom, she noticed Pam in the courtyard. Miss Norman's eyes were 52 feet above the ground, and Pam was 38 feet from the building. Draw a diagram of this situation. What is the angle at which Miss Norman had to look down? That is, what is the angle of depression? Assume that Miss Norman was looking at the spot on the ground below Pam. So, let's see here. Here's our building, 3 stories up, looking out the window, down to the ground, where Pam is standing. All right, so what information do we have? We know that Miss Norman's eyes were 52 feet above the ground, so 52 feet above the ground, and Pam was 38 feet from the building. Now, obviously, my picture is not drawn to scale, so we drew a diagram of this situation, but what is the angle at which Miss Norman had to look down? What is the angle of depression? So what happens is, here is the line of sight of Miss Norman. So when she looks down, here's the angle that she's actually looking at. So this is our value, our angle that we're trying to find. Now, it doesn't appear to be part of the triangle, but if you think about this line up here, the line of sight, and the ground, those lines are parallel. So this angle and the angle from the ground up to Miss Norman are exactly the same angle because they're alternate interior angles. So that is part of the triangle that we're looking for. Since we have the opposite side and the adjacent side given to us based on that angle of theta, then we can use tangent. Since it's a right triangle, we can say tangent of theta is 52 over 38. And remember, since we are looking for the angle measure, we're going to have to use the inverse of tangent. So what angle gives us a ratio of 52 over 38? Plug that into your calculator and see what you get. And so theta is approximately 53. We'll go 2 decimal places to the nearest hundredth. 53.84 degrees. So what is the angle that Miss Norman had to look down? That is the angle of depression. Once again, looking at the spot on the ground below Pam, and that would be 53.84 degrees. Question 102. For each pair of triangles below, determine if the triangles are congruent. If the triangles are congruent, then complete the correspondence statement, state the congruency property, and record any other ideas you use that make your conclusion true. Otherwise, explain why you cannot conclude that the triangles are congruent. Note that the figures are not necessarily drawn to scale. So on part A, we have triangle ABC is congruent to what? Well, let's see what we have marked. We know that this angle is congruent to that angle. We also have this angle over here congruent to this one. And we also have this side length that is congruent in both triangles. So we have 2 angles and a side length, which is enough to prove congruency. So we do know they are congruent because of angle, side congruency. And triangle ABC would match up to triangle A, B matches up with D, and then C matches up with its point C, so it's congruent to triangle ADC. Why did I put a B though for some reason? Let me fix that. ADC. And once again by angle, side congruency. Part B, SQP is congruent to triangle what? Well, once again, let's take a look. We have this side length is congruent to that one, so that's good. We also have the side length that they're sharing again using the reflexive property, so that's 2 side lengths. And then we have the right angle, so we know their angle is also the same. On this one, we have enough because we can prove, since it is a right triangle, we can prove by hypotenuse, leg, The hypotenuse is the QP and the QR, and then the leg would be the QS. So that is enough to prove that they are congruent, and SQP would be congruent to SQR. Part C, PLM is congruent to triangle what? Well, let's see what we have. We have an angle, L congruent to angle N. We also have the angle in the middle, which would be vertical angle. Those two are congruent. But we don't have anything else. An angle similarity, but not angle congruency. So because of that, we need some additional information. So therefore, we don't know that the triangles are congruent. As of right now, we only know two angles are congruent. So explain why you cannot conclude that the triangles are congruent. We don't have enough information. There is no such thing as angle congruency, but there is angle similarity. Once again, but not for congruent. So you would need another side length somewhere in here to prove that they are congruent. Part D, triangle WXY is congruent to what? Well, once again below we have vertical angles, so we can say that those two angles are congruent. It also says that the midpoint of WT and XZ is right here of both of them. So that means this is congruent to this length, and this one is congruent here. So it does appear by side angle side congruency that we are able to prove that. We also used vertical angles to help with that, and the midpoint of both line segments. So WXY, so that triangle, we got to match everything up. So W would match up to T, X would match up with Z, and then Y matches up with Y. So triangle TZY. Triangle EDG is congruent to triangle what? Well, we have parallel sides, so we can use our alternate interior angles, and that means that this angle here would be congruent to this one. We also know that using alternate interior angles of the other parallel lines that this angle would be congruent to this one. So we have two angles, and then we also have the side that they're sharing in common. So by angle side angle, we are able to prove congruency, and E would match up with G, D would match up with F, and G is going to match up with, or at least on that one I gotta be careful, so G, F, and then E. And then the last one, triangle ABC. So we have ABC, we're looking at this triangle. You can see A would match up with D, that has a length of 7, and then this right here matches up with the BC, and this part right here is 3, this part right here is 3, so that length would have to be the same, so therefore this length right here would have to be the same as this length of this triangle. So by side, side, side congruency, we know they're congruent, and ABC would match up, so A would match up with D, B would match up with E, and C would match up with F. So triangle ABC is congruent to triangle DEF.